Hello, and welcome back. Now that our core game is built, it's time to discuss topics not directly related to gameplay, such as online game service platforms. In this section, we'll finish off the course by discussing Steam functionality and alternatives to Steam for online services. Further along in the section, I'll be presenting you with a series of challenges to tackle in order to take our project to the next level, and then we'll finish off with a title recap that will recap all of the main knowledge we've gleaned over the course of these videos. So in this video, I'll be taking you through the process of activating Steam platform services within our project, and then connecting our already built session functionality into Steam's server list and searching services. This will allow players to host their servers behind normally inaccessible routers by utilizing Steam's net drivers. Additionally, we'll go through and make a few small changes to our code to fix a few bugs and quirks involved when working with the Steam platform. So let's jump right in. Enabling the Steam platform within Unreal Engine is an extremely easy process. Everything that needs to be done to enable the platform will be done inside our default engine.ini file. So we'll move over to Visual Studio into our default engine.ini file in the config folder. The first thing we're going to do is change our default platform service under the online subsystem heading we added in our initial section on online subsystems to Steam instead of null by commenting out the original line and adding a line designating Steam. So, online subsystem, we comment out the line, and then we add default platform service equals Steam. After this, we need to add our Steam net driver definition that will allow players to route their connection through Steam by adding it to a new game engine heading and then defining the net connection class name. So we're going to add script/engine.gameengine plus net driver definitions equal parentheses def name equal game net driver, comma driver class name equal online subsystem Steam.steam net driver, comma driver class name fallback equal online subsystem utils.ipnet driver. We'll follow that up with a new heading /script/online subsystem Steam.steamnet driver, and then connection class name equal online subsystem Steam.steamnet connection. Finally, to finish off inside this file, we need to specify various Steam settings under an online subsystem Steam heading. So, online subsystem Steam will enable the platform with beEnabled equal true. We'll give it the app ID of 480 as that's the developer app ID that Steam developers, Steam dev app ID equal 480. We set the default query port for Steam, game server query port 27015. We set our game version, which we'll just set as 1.0.0.0. We'll enable cheat detection with b back enabled equal 1. We'll allow NAT traversal with b allow P2P packet relay equal true, and we'll give it a connection timeout of 90, P2P connection timeout equal 90. And finally, to prevent the subsystem from reading other achievements that may be defined in the parent.ini file, we're going to define achievement_0_ID equal empty quotes. With all these added, we'll return to the editor and go over to our Edit plugins into the Online Platform category, and then we'll enable the Online Subsystem Steam plugin. You'll be prompted to restart the editor, which we'll do now. While the editor is restarting, we have to make a few changes to our project due to some quirks in Steam integration. Firstly, we need to enable seamless travel on our game mode as to ensure that when we restart the game that the clients correctly follow our server along. So, in our mastering Unreal game mode base.cpp's constructor, we're going to define use seamless travel equal true. Then, due to the fact that we're now using seamless travel, the way we're getting our player controller in our game state and game instance classes needs to be changed, as getFirstPlayerController can return remote controllers when seamless travel is enabled. So in our platformer gamestate.cpp and platformer gameinstance.cpp, we're going to replace all instances of getWorld getFirstPlayerController with getWorld getFirstLocalPlayerFromController player controller. Finally, when performing seamless travels, there's a bug in the way Unreal Engine handles widgets when traveling in that they don't properly get destroyed when the travel completes. This means that our changing level loading screen doesn't disappear and we lose the reference to it when restarting the match. So what we're going to do is, at the beginning of our waiting for players match state, we're going to iterate through all active user widgets, and if one is of the class CChangingLevel, we'll remove it from the viewport. So at the beginning of our eWaitingForPlayers match state in platformer GameState.cpp, we're going to add for TObjectIterator uUserWidget iter semicolon iter semicolon plus plus iter. And within the for loop, we're going to cast it to uUserWidget with uUserWidget liveWidget equal iter. Then we check whether or not the widget has a world, and if it doesn't, we ignore it as it's probably within the content browser. So if not liveWidget getWorld, continue. And then else, if it's of class CChangingLevel, if liveWidget getClass is child of CChangingLevel, liveWidget remove from viewport. With those fixes out of the way, we can return to the editor and compile our project. Once the project is compiled, you can launch your standalone game, ensuring Steam is updated and running in the background. You can press your Steam Overlay hotkey, which defaults to Shift plus Tab, to have the Steam overlay appear, telling you you're running Spacewar. To test out our full network functionality, however, we're going to need a second computer with a different Steam account in order to join each other's servers. So, we're going to package our game and run it on our second computer. As seen on screen, I've already done this and hosted a server on my second computer. I joined the server, and you can see that any movement I do on my second computer is replicated over to my client machine over Steam. All of the network functionality we've built using Unreal Engine's online subsystem session interface works flawlessly over Steam.